Ik sta weer op de Formnext. Het is 2025, hier op de stand van het Spaanse Meltio 3D-printerfabrikant van prachtige metaalprinters. Hier achter mij hun flagship model, de M600, met een bouwvolume van 30 bij 40 bij 60 centimeter. Hier op de stand heeft Meltio prachtige samples gedemonstreerd en van verschillende applicaties. En die ga ik met Giorgio presenteren. Giorgio, good morning. Goedemorgen.
Good morning, Ahmed.
Hello. What do you have here for me?
So this is a component for trenching, and it is a cast component. We didn't print it, but we are showing the capabilities of using wires such as tungsten carbide in a nickel matrix. This is manufactured by our partner Welding Alloys, and it is a cord wire that allows for a very good wear resistance on parts that they would experience a lot of wear in operation.
Yeah, impressive. And what caught my eye here is this naval propeller that you displayed. Two materials?
Yes, this is a naval propeller with a stainless steel hub and marine bronze blades, so you have the possibility of merging two materials in the same build. This was done on the engine robot, and this
which is 5 axis, of course.
Yes.
Yeah.
The full capabilities of 5 axis. So this one is done radially, while this one is done in 3 axis within the Meltio-600. And we started with steel, then we switched to bronze for the driving band, and back to steel, all in one build.
Yeah, because the most people watching my videos know that the Meltio is capable of having up to 4 metal wires on the machine. And this is a perfect display of two metals printing on one part. Yeah, and then this is really impressive, huh? A huge part. It's not printed on the Meltio, but it's a display of restoration. Can you tell me something about it?
Indeed, when you have a system as versatile as our robot cell, you have the capability of doing not only manufacturing but also repair of existing components. Sometimes there are components that they could still be valuable just with local repair instead of full remanufacturing.
Yes.
And in this case, we have hard tool steel replaced on each of the teeth.
Yeah.
So making this part fully capable of going into operation again.
Yeah, it's absolutely impressive. And also here, I know this is a component that I personally see coming from the industry a lot. These impellers that are used for factory production lines that are very, very difficult to get.
Yes, indeed, this comes from the pump of a Navy ship, and it is a very difficult component to manufacture. Here it was printed in our engine robot with a radial strategy, starting from a shaft and then growing the part radially in order to obtain all the intricate features that are necessary for the operation of the pump.
Yeah.
And you can see here where it was machined that we have a full density, a very solid component.
Yeah, this is a perfect display of hybrid manufacturing, right? So it's 3D printed from the bottom up and then CNC'd to get the surface finish, and really the CNC work on this part shows how dense Meltio is capable to manufacture their parts. It's very impressive, and a lot of companies in the industry looking for this. And then this one, a mold. Tell me something about this, because I heard something about internal cooling channels.
Indeed, this is a mold insert for injection molding in the automotive sector, and it is made out of tool steel. And the peculiarity is the fact that we have also internal cooling channels. That is something that can be done conventionally, but it requires drilling from different areas, then welding, and it's an additional process. With a machine such as the Meltio-600, you can print from the ground up the part with all the features that you need for a proper performance and cooling, and then have it machined, heat treated, and put in operation at a fraction of the time that would require for conventional manufacturing.
Yeah, very impressive of manufacturing such a complex geometry, and then again hybrid manufacturing with the milling work. And this, I think everybody recognizes this, right?
Yes, this is the prototype of an engine block. This was designed by the American company Polymotor to investigate the capabilities of metal 3D printing for the manufacturing of full engine blocks. And you can see that it has a very good resolution. Even though it is a large part manufactured with a robot, and basically you would need to do some machining for finishing and putting an operation on the inside, but all the external areas can be left as they are printed.
Yeah, so, and just to emphasize again, you say it's a prototype, but it's not just for display, right? So this can also be a functional part.
Indeed, it's a prototype for a functional part, and this is the direction that Polymotor will be going in the future.
Yeah, very, very, very impressive. And finally, this part, can you tell me something about this as well?
Yeah, this is a study for a heat exchanger and also a capability demonstrator regarding the new alloys that can be unlocked with the blue laser technology of the Meltio 600.
Yeah.
In this case, we have a copper chromium zirconium alloy.
Yeah.
Basically more than 99% of pure copper. And the part is really intricate and fascinating.
Yeah, very fascinating to see. Well, thank you so much Giorgio voor de video. En jullie bedankt voor het kijken. We gaan de video afronden. Hebben jullie nog vragen over de producten of applicaties van Meltio? Neem contact op met ons. Een van mij of een van mijn collega's bij ProductionToGo. En ik zie jullie weer op de Formnext van volgend jaar in 2026. Bedankt. Doeg!